Welcome back. Let's look at example 2, which is a problem-solving application. So Sammy has a gift card. She has already used $14 of the total value, which is $30. Write, solve, and graph an inequality to show how much more she can spend. Now, I really want to talk to you about applications. This is like it's like a simpler one. You might just be able to read it and figure out the answer just like in your head. Or maybe you read it and you don't and you have no idea, and that's totally okay too. But what we're trying to learn in this class and what I'm trying to set you up for is being able to take words and then convert them into mathematical equations. Now, whenever you do that, it becomes really, really super important the higher you get in mathematics. However, to get that skill, you have to start with things that are simple, right? Like whenever you learned how to read, well, first you learned what the letter A was, and it made the A and the A sound, right? So it's kind of like baby steps. So that's the same thing here. So even though you might just be able to figure this out in your head and you're like, oh, I can just figure this out. Why do I have to do all the rest? The issue with this application is not that you can figure out the answer, but do you have the skills to be able to identify what the variable is, define the variable, write an inequality, and then solve it? And so it's really that whole entire process we're going for here with this example. It's not just determining the answer. Okay, so it's more of a broader scope, and this is just setting down and getting a really strong foundation so that as the story problems get harder and harder, which they will, you will have the skills to be able to read it and be like, okay, that's my variable. I'm going to just call that X or any letter. I can write an inequality. I can solve it with my skills, and so on. Okay. So what I need you to notice is when you read this particular application, there's all different types of applications out there, okay? And I like to just kind of like put applications into particular groups, and I know which group it is by different keywords, okay? So for instance, when I'm dealing with something about a car and it's going a particular speed, and there's distance and there's time, and it's something about that, I know automatically that it's a distance equals rate times time problem. Okay, so anytime I read something and it starts to talk about these different characteristics, I can go boom, this is the equation that I'm going to be using. Okay, there's other different types, and so there's all different types. Like if I'm talking about I'm reading something and it's talking about like fencing, and I need to make fencing material for a rectangular fence. Well, and then it wants to know, well, how much fence it is. Well, boom, I know that for a rectangular fence, and it wants to know the fencing, that's the distance around, I'm going to be finding the perimeter, which is going to be the equation P equals 2L plus 2W. Okay, so those are keywords where I know exactly where I need to go. And so that's a certain type of story problem. And this is... and the further we get in this class, the more in the different types of, so anytime I'm talking about this type of thing, even if it's not fencing rectangular, maybe it's the border around a room, I know that I'm going to be using this type. It fits in this category. So the category of this is, it's a type of story problem where they give you a total, and then the total is made up of parts, and those parts are usually added together, okay? So this is a total equaling the parts that make up the total. So when we're reading this, I want you to identify, okay, well, what is the total and what are the parts? So I'm gonna say the total is green, and then the parts are going to be, let's just say they're gonna be orange. Okay, and we add the parts together, and the parts make up the total, okay? So That's what type of problem this is. So a couple things. We need to find the variable before we do this. Okay, so what is the variable? Sammy has a gift card. She has already used $14 of the total value, which was $30. Write and solve and graph an inequality to show how much more she can spend. So a lot of times your variable is at the end. Well, it's in here, but it can also, like, they always ask the question about the variable. That's the thing you need to figure out. So write and solve and graph an inequality to show how much more she can spend on the gift card. Okay? So I'm just going to say let M equal the amount left, or the amount remaining would probably be better. Amount remaining on gift card. That's what we're trying to figure out. Okay? All right. So we'll call that M. Let's see if we can identify what the total is. So Sammy has a gift card. She has already used $14 of the total value, which is $30. So it's telling us the total value is 30. Okay? Then we want to figure out, well, what is that total made up of? Okay, so the total is made up of $30. Sammy has a gift card, and she already used 14 of the total value. So that $30 is, part of it was that 14 that's used. So she has 14 that's used, and if 14's used, the other part is going to be the unused portion, which is how much more, you know what I mean? That's going to be our variable that she has to spend. So, what you have is you're going to have two sides of this inequality. You're going to have the total, you can have it on this side, and then we're going to have the used, amount used, and then the amount used is going to be added to the amount that's unused, right? And both of those values, the amount used and the amount unused, those add up to the total amount. Okay, so let's go ahead and substitute those values in. So we're going to have the total is 30, and then the amount used is 14, plus the amount unused, we're using M. And then we're dealing with inequalities. That means we have to use an inequality symbol here. So we know that 30 is the maximum. 30 is the biggest, right? This is the amount that's on the gift card, right? But this amount on the gift card cannot exceed 30. So it has to be, you know, so 30 is the biggest. So that means the alligator is going to eat the 30. And it's going to be, but it can also equal 30. So we're going to have this, okay? So this would be our kind of original inequality. And then what we're going to do is we're going to solve this. Okay, so I want to get M by itself. So I need to get rid of this 14. So inverse operation would be to subtract 14 to both sides. That cancels out. I'm left with, okay, I got to borrow, make that a 10. This is going to be 6. That's a 2. That's a 1. Okay, that looks great, but remember I have to write that variable on the left side, so I'm swapping sides, but the alligator still has to eat the 16. Okay, so this is what M equals. So I have my original inequality there, and then I have my answer here. And then, so this really means that the amount used is less than or equal to 16. So how much more can she spend? Well, she can spend up to $16. So I'm going to graph that here. I'm going to have my 0. And then I think I'm just going to make a 16. And then what's my circle? Is it going to be closed? Well, it can include 16. So it's going to be a closed circle, and then it's really everything less than 16 going that way. Okay, so we wrote our inequality, we solved it, and we graphed it. So how much more can she spend? Well, she can spend $1 all the way up to $16, but there's no more money after $16 on that gift card. There's only $16 left. So she can spend anywhere really between $0 and $16. All right, perfect. Let's move on to the next example. Check it out, example 2. The recommended daily allowance, RDA, of iron for a female in Sarah's age group is 14, which is 14 to 18 years, is 15 milligrams per day. Sarah has consumed 11 milligrams of iron today. Write and solve an inequality to show how many more milligrams of iron Sarah can consume without exceeding the RDA, the recommended daily allowance. Okay. So, remember how I was talking about different types of story problems? This is also another one that's going to be total equaling parts, okay? We have the total recommended. She has already taken so much iron and she still has another bit of iron. So that's going to be this type of problem again. So this is how we're going to set up our inequality. So it's written as an equation, but we just put inequality. So we're going to have the total on one side, and then we're going to have the parts that make up that total on the other side. So let's just go ahead. First, we need to go ahead and figure out, well, what is our variable going to be? And a lot of times that variable is written in the, like at the end, like what they're asking you to do. So the recommended daily allowance, RDA, of iron for female in Sarah's age group is 15 milligrams per day. Sarah has consumed 11 milligrams of iron today. Write and solve an inequality to show how many more milligrams of iron Sarah can consume without exceeding the RDA. So that's really our variable there. So we're going to say let... how many more milligrams of iron can consume. I don't know what letter. We'll just make it an I for iron. I don't know. It doesn't matter. Let I equal amount of iron Sarah can consume. Consume without exceeding the RDA, recommended daily allowance. Perfect. Okay, so since this is a total and a parts thing, let's identify what the total is. I'm going to have that in green. So the recommended daily allowance of iron for a female in Sarah's age group is 15 milligrams per day. So that is our total. Now that total is made up of parts. So the first part is Sarah has consumed 11 milligrams of iron today. So that's one part. That's part of the 15. The 15 is made up of what she's consumed and then what she still can consume, right? How many more milligrams of iron can Sarah consume? So that's the other piece. So as we write our inequality, that's going to be made up of the total and then the already consumed, already consumed amount, and then the, the still can consume, or, how would you say that? Already consumed and how many more can consume? And can consume, can still consume. The amount, we'll say the amount that can still be consumed. Consumed, why am I having a hard time spelling consumed? Okay, and these are added together, right? Because that makes up the total. The amount that she's already consumed and the amount that she can still be consumed without going over that RDA, which is our variable. So then we just substitute in those values. So the total is 15, right? The amount that's already consumed is 11, plus the amount that can still be consumed without going over the RDA would be our I. And when you add these two things together, they cannot go over 15. So 15 is the biggest that this can be. So that means the alligator is going to eat the 15. But it says is 15. So it can be 15. So that means it can equal. So there is our inequality right there. And then what we want to do is just solve it to figure out what is I, how much can she consume. And you can probably just look at it and figure out. However, we want to practice this skill. It's not just finding out the answer. It's just practicing the skill and being able to do this, because you're going to need this, especially when this stuff gets harder, because it's harder to learn all this when the problems are super, super hard. So we want to get I by itself, so we're going to do the inverse operation, subtract 11 from both sides. We have 15, take away 11, that's 4. Can you see that? Okay, 4, that cancels at 0. We have I, and we have to write the variable on the left side, right? So we're going to write I, 4, they swap sides, but the alligator still has to eat the same thing, so it's eating the 4 here, so it has to continue to eat the 4 there. Boom, there we have it. And then we just have to graph it. So make 0 here, 1, 2, 3, 4, super easy. We go to 4, is it going to be a closed circle, open circle? It can include 4, so that means it's going to be a closed circle, and it can be anything less than or equal to 4. So these would all be solutions right here. All right, so the amount of iron that she can consume is either 4 or less milligrams. All right, that's it. We'll see you in a little bit for example 3.